Okay, here we go. So this video is to review the algebraic or analytic components of Unit 2. We will be doing 2 of every type of problem, so ideally speaking, because this is review, once I put up the first of the 2 problems for that topic, you really should stop the video so that you can give yourself a chance to try it on your own. And then restart the video when either you are stuck or have an answer that you are ready to check against. This will allow you to determine whether or not you need to do that second problem, right? If you do the first one and it's a piece of cake and you got it, well, maybe you want to move on and focus on a different topic for studying. But if the first one was a little bit rough, or you just want to kind of do it to make sure you've solidified that topic, then you can do the second problem, okay? And so here we go. We're going to work through 2 of every topic. The first one, actually the first number of them are going to fall into these directions, solve for x. But I'm still going to group them by similar concept. And so the first problem we're going to put up is x squared minus 6x equals 7 minus 4x. Okay? So go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, so to solve for x, I want to get this to equal 0. So to do that, I'm going to go ahead and add the 4x over and subtract the 7. And so we would have our x squared, negative 6x plus 4x is negative 2x, and then the minus 7. And then you'd be looking for, well, what could I do? I could potentially factor, but unfortunately there's nothing that multiplies to 7 that adds to 2, so factoring wouldn't work. And as you continue to tick your way through the different strategies that we have for solving for x, we end up landing on the fact that this one needs quadratic formula. Okay? So here we go. We have x equals negative b plus or minus radical b squared minus 4 times a times c, all divided by 2a. And then this does simplify, so we have x equals 2 plus or minus 4 plus 28 is 32. The square root of 32, a perfect square that comes out of 32 is 16. So the square root of 16 is 4. And then this does simplify. 2 divided by 2 would be 1. 4 divided by 2 would be 2. And we've got our answer. Okay? So let me go ahead and give you another one. 3x squared minus 2x plus 1 equals 0. Go ahead and pause the video, give this one a shot, restart it when you're ready. Okay, so this one, again, kind of ticking through our possibilities. Could I factor? Well, then I'd be looking for 2 things that multiply to positive 3, which would be either positive 1 and positive 3, or negative 1 and negative 3, and add to negative 2. And unfortunately, there's nothing there that would factor this function, or this expression. And so then you'd be, again, ticking your way through the different solving strategies we have, but eventually landing on quadratic formula. Oh, and we already equal 0, so we're good to go. So we have x equals negative b plus or minus radical b squared minus 4 times a times c, all divided by 2 times a. Okay, and so then we have x equals 2 plus or minus the square root of negative 8. Okay. And then the square root of negative 8, a perfect square that comes out of that is 4, and so we'd have 2 with a root 2 left over. And then the square root of a negative is an imaginary number, so that'd be I, all divided by 6. Okay? And then this does simplify. There's a 2 that comes out of everything, so we'd have 1 plus or minus 1i root 2 over 3. And you've got your answer. Okay? Okay, next up, still solving for x. Right? Like I said at the beginning, most of these are going to fall into this instruction, solve for x. Okay? And we have 4x cubed minus 4x squared minus 3x equals 0. Okay, go ahead and pause this video, restart it when you're ready. Okay, so when it comes to this one, we're going to be, again, thinking about strategy. So one strategy is a GCF factor. I notice I have an x in common, so I can pull that x out. We have 4x squared minus 4x minus 3. And so then we would be looking at, well, can I factor this again? So I'd be looking for two numbers that multiply to negative 12 and add to negative 4. Two numbers that multiply to negative 12 but add to negative 4 are negative 6 and 2. And so this will factor. So we're looking at breaking up our 4x and our 3 and creating negative 6 and 2. So 4x can be broken up as 4 and 1 or 2 and 2. 3 only breaks up as 1 and 3. So let's go ahead and focus first on that back piece, because I know it's going to be 1 and 3. The question is, do I want to use 4 and 1 or do I want to use 2 and 2 for my front term? Again, I want to create negative 6 and 2. Well, for 3 to become negative 6, it would need to get multiplied by 2, not by 1 or 4. And so we're going to use the 2x and not the 1 and the 4. And again, I want it to be negative 6, so we're going to do negative 3 and positive 1. And you can always double check that you broke it up correctly. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x plus 2x, which is negative 4x. And 1 times negative 3 is negative 3. So I know I factored it correctly. So then we're going to solve. X equals 0. 2x plus 1 equals 0. Subtracting the 1 over, we have 2x equals negative 1. And dividing the 2, we get x equals negative 1/2. Okay. And then here we have our 2x minus 3 equals 0. So adding the 3, we get 2x equals 3. Dividing the 2, we get x equals 3/2. Okay. Okay, I'm going to go ahead and give you another one here. Let's do this one. 3x squared minus 19x plus 10 equals positive 8x. We got positive 8x. Okay, go ahead and pause the video, restart it when you are ready. Okay, so we need to get this to equal 0. So to get this equal 0, we're going to go ahead and subtract this 8x to the front. Okay. And so then simplifying this, we have 3x squared minus 27x plus 10 equals 0. I am so sorry, ladies and gentlemen, I did make an error. Okay, so we're going to restart this one. Again, pause the video when you are ready to go, but I did want that to be a negative 8x. I'm sorry. So negative 19x plus 10 equals negative 8x. For those who worked through that last one, you would have had to use quadratic formula, I believe, and that would have been a nightmarish quadratic formula. So go ahead and pause this one, give this one a shot, and then restart it when you are ready. Okay, so here we go. Want it to equal 0, so let's go ahead and add 8x over to the other side. Okay. We have 3x squared. Negative 19 plus 8 is negative 11x plus 10 equals 0. Okay, so then you'd be looking at, well, what else could I do? Could I factor? Could I do quadratic formula? And actually, you could do quadratic formula. You can always do quadratic formula on a quadratic. But this one does factor, and so if you can find two numbers that multiply to 30 and add to negative 11, you can potentially speed up the process a little bit. Quadratic formula would be much more time consuming in this case. So two numbers that multiply to 30 but add to negative 11 are negative 5 and negative 6. And so that's what I'm going to be wanting to create as I break this up. The 3 breaks up as 3 and 1. The 10 breaks up as either 1 and 10 or 2 and 5. Looking at the numbers I'm trying to create, I'm pretty sure it's not going to be the 1 and 10. But it's good to recognize that's a possibility. So like I said, the 3x is going to break up as 3x and x. And I want to create negative 6. Well, if I multiply 3x by negative 2, I'll have negative 6. If I multiply the x by negative 5, I'll have negative 5x. And then again, you can double check. 3x times x is 3x squared. 3x times negative 2 is negative 6x. Minus 5x is negative 11x. And negative 5 times negative 2 is 10. So I know I factored correctly. Okay, so this first term, where does this equal 0? Well, if I add that 5 over and divide by 3, we get x equals 5/3. Okay. And then the second term, if I add the 2 over, I get x equals 2. Okay. So here we go. Next one, still solving for x. I'm going to give you 1/2 times the quantity of 3x plus 7 squared minus 2 equals 48. Okay. Go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, so this one, I notice I have a square, so I'd like to be able to solve this using squares. So let's go ahead and add the 2 over. We have 1/2 3x plus 7 quantity squared equals 50. And then to get rid of this 1/2, we'd be multiplying both sides by 2. And so we have 3x plus 7 squared equals 100. Okay, and so then square rooting both sides. The other option would be foiling this out and then getting it to equal 0 and either factoring or doing quadratic formula. But I'm going to do the square root. So square rooting both sides, we get the absolute value of 3x plus 7 equals the square root of 100 is 10. And then an absolute value, remember, has a positive leg and a negative leg, depending on what part of the function you are looking at. And so you have to break it up as the positive and negative. Okay, so this first one, if we subtract the 7, we get 3x equals 3. And dividing the 3, we get x equals 1. Over here, you have to decide, do you want to distribute the negative or do you want to divide? On this one, I'll go ahead and distribute. The next one, I'll divide, because it doesn't matter. Just two different routes of getting to the same answer. Adding the 7 over, we have negative 3x equals 17. And dividing the negative 3, we get x equals negative 17 thirds. Okay? Okay, so next up, we have, let's do solve for x. If f of x equals x minus 5 quantity squared, and g of x equals 3x plus 1, what is negative 4 times f of g of x equals, oh, 1 second, let me double check something. I want to make sure I give you a good problem here. And I wrote it down wrong. Okay, we are making this equal negative 64. Okay, go ahead and pause the video, give this one a shot, restart it when you're ready. Okay, so plugging in, we have -4, my f of g of x, so g is getting plugged into f over here. Okay, so g is getting plugged into f. We have 3x plus 1 minus 5 squared, which cleans up to 3x minus 4. Dividing that -4 over, we get 3x minus 4 squared equals 16. Square rooting both sides, we get the absolute value of 3x minus 4 equals the square root of 16 is 4. And so then we have our positive leg, 3x minus 4 equals 4, and our negative leg, 3x minus 4 equals -4. Oops. I'm going to divide the negative on this one. Okay, our positive leg and our negative leg. Okay, so adding the 4 over here, we get 3x equals 8, and dividing by the 3, x equals 8/3. Over here, so I distributed in this first example, so let's go ahead and divide in this one. 3x minus 4 equals -4. And if I add this 4 over, we get 3x equals 0, which means dividing the 3, x equals 0. Okay? Okay, let's go ahead and do this one next. Let's do a cubic one. X cubed, so still solve for x. X cubed plus 216 equals 0. Okay, go ahead and pause the video, restart this one when you are ready. Okay. Okay, so here we go. Cubic factoring. This is the same thing as x cubed plus 6 cubed. Okay, so we have first term, second term, first term squared, first term times second term squared. And then for your signs, you are soaping it, right? So same, opposite, always positive. Okay, so here we go. Solving this, x plus 6 equals 0. If I subtracted the 6 over, we'd get x equals -6. On this side, we have quadratic formula. So x equals -b plus or minus radical b squared minus 4ac all divided by 2a. Okay, so then simplifying this, we have 6 plus or minus 36 minus 144 is -108. Okay, what is the value that comes out of 108? That's a perfect square. That'd be 36. And so we know we have the 6 coming out. And there would be a 3 left over inside. The square root of a negative is I. And then simplifying, 6 divided by 2 is 3, plus or minus 3i root 3. Okay, here's another. 5x to the 4th minus 5x equals 0. Go ahead and pause the video, restart it when you're ready. Okay, factoring, we have a GCF that comes out here, so 5x, left over we'd have x cubed minus 1. And then that x cubed minus 1 factors, it's a difference of 2 cubes, so we have, because this is x cubed and 1 cubed, first term, second term, first term squared, first term times second term squared. And then signs would be SOAP, so same, opposite, always positive. Okay, so what makes this equal 0? Well, If 5x equals 0, if I divide that 5 over, we get x equals 0. For x minus 1 to equal 0, if I add that 1 over, we get x equals 1. And then quadratic formula. So we have x equals negative b plus or minus radical b squared minus 4ac, all divided by 2a. Simplifies to x equals negative 1 plus or minus radical negative 3. And that negative 3, there's no perfect square that comes out of 3, but I can rewrite that negative as I. And since there's nothing that simplifies, that's our answer. Okay, let's do one more with solving in our equal signs here. So let's do this guy. So this problem has a corresponding problem in the graphing review video. So I do encourage you, like I said at the beginning, to kind of use both videos to help out. But we solved this problem initially graphically. Now let's go ahead and solve for x algebraically. Okay, so x squared minus 16 absolute value equals 7. Okay, go ahead and pause the video and restart it when you're ready. Okay, so here we go. We have our positive, negative legs. So x squared minus 16 equals 7. And negative x squared minus 16 equals 7. Okay. So x squared, adding that 16 over to the other side, we get 25. We get 23. Okay. And then square rooting both sides, we get the absolute value of x equals the square root of 23. There's no perfect square that comes out of root 23, so we're going to leave it that way. And then there's the positive leg, so that's one value, and the negative leg, and so my other value of x is negative root 23. Okay. Over here you have to choose whether or not you want to distribute the negative or to divide the negative over. It is your choice. I'm going to go ahead and divide it over on this one. So x squared minus 16 equals negative 7. Adding the 16 over, we get x squared equals 9. And so if I square root both sides, we get the absolute value of x equals 3. And so then we have our positive leg, x equals 3. And our negative leg, negative x equals 3, which means x equals negative 3. And we have our 4 values here from my absolute value. Okay, let me give you another. Absolute value of x squared minus 2x minus 8 equals 8. Okay, go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, so positive leg, negative leg. X squared minus 2x minus 8 equals 8, my positive leg. And negative x squared minus 2x minus 8 equals 8, my negative leg. Okay, so solving this. On this side, I'm going to go ahead and subtract this 8 over, so we get x squared minus 2x minus 16 equals 0. And then you'd be looking at this going, okay, well, can I factor, is there anything that multiplies to negative 16 that adds to 2? Negative 2. And unfortunately, there isn't, so then it's quadratic formula. X equals negative b plus or minus radical b squared minus 4ac, all divided by 2a. Which simplifies. 4 plus 64 is 68. Okay. The perfect square that comes out of 68 here is 4. And so square root of 4 is 2. Left over inside, we would have 17. And then this does simplify one step further, which is the 2's can all cancel, leaving me with 1 plus or minus root 17. Okay. On the other side, same decision. You can distribute or divide. I'll go ahead and divide. X squared minus 2x minus 8 equals negative 8. Adding this 8 over to the other side, we get x squared minus 2x plus 0 equals 0, which does give me with a factorable thing. There's a greatest common factor here that I can pull out. You also could do quadratic formula, but greatest common factor is definitely faster in this way. And so then x would equal 0, and x minus 2 would equal 0, meaning adding the 2 over, x equals 2. Okay? Let's go ahead and do some absolute values here now. Not absolute values, I'm sorry, some inequalities. We've been doing some absolute values. Let's do 2 plus negative 5 times the absolute value of 4x plus 1 is less than or equal to 17. Okay, go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, so I'm going to go ahead and isolate the absolute value. Let's subtract the 2 over. We get negative 5 times the absolute value of 4x plus 1 is less than or equal to 15. And then if I divide the negative 5 over, we get absolute value of 4x plus 1. Now remember, when you divide by a negative, you have to flip the sign of that inequality. 15 divided by 5 is negative 3. And then looking here, is an absolute value bigger than a negative? Yes, for all values of x, right? Doesn't matter what I plug in here, an absolute value is always greater than a negative. And so then this answer is infinitely many solutions. If this said the absolute value was less than the negative, well, an absolute value can never be less than a negative, and so that would be no solution. If this negative 3 had been a positive number, then I would have split up as my positive and my negative leg, just like we've been doing in all the previous example problems so far. But in this case, absolute value is always bigger than a negative, and so we have our infinitely many solutions. Okay, let me go ahead and give you another here. Let's do 4 minus 2 times the absolute value of 3x minus 8 is less than negative 16. Okay, go ahead and pause the video, restart it when you are ready. Okay, so subtracting this 4 over to work on isolating our absolute value, we would have negative 2 absolute value of 3x minus 8 is less than negative 16 minus 4 is negative 20. Dividing by the negative 2, we have 3x minus 8 absolute value is, remember when you divide by a negative, you have to flip the sign. Okay, in this case, it is possible for an absolute value to be greater than 10, so we're going to go ahead and do our positive leg. 3x minus 8 is greater than 10. And our negative leg, negative 3x minus 8 is greater than 10. Okay, adding the 8 over, we get 3x is greater than 18. Dividing the 3, we get x is greater than 6. On the other side here, I've been dividing by the negative, so I'll go ahead and distribute on this one. Negative 3x plus 8 is greater than 10. Subtracting the 8 over, we get negative 3x is greater than 2. And then dividing by the negative 3, we get x is less than negative 2/3. Remember, when you divide or multiply by a negative, you have to flip the sign. Okay? If I were to sketch this on a number line, negative 2/3 and 6, I have no equals, so these would be open dots. And I want first my x to be greater than 6. Well, which direction is greater than? It's to the right. Negative 2/3, I want it to be less than negative 2/3. Which way is less than? To the left. And so I can see here that this is an or statement because it's going in either direction. And so to express my intervals, this region over here that my first arrow is covering is everything from negative infinity to negative 2/3. And my second region here is everything from 6 to infinity. And we are doing parentheses because there is no equals. That's why it was an open dot on our number line. Okay. Let's go ahead and do this one. So this is another problem that corresponds to one of the graphing review ones. So again, a reminder to kind of poke your head over that direction and make sure to take a look at them. But we're going to solve this one algebraically. So I want to know, okay, where is f of x less than or equal to g of x less than h of x if f of x equals 1, g of x equals 1/2 times the absolute value of x minus 2, and h of x equals 3. Okay, so go ahead and pause this one. Restart it when you are ready. Okay, so let's go ahead and set this up. Okay, first we want to figure out where is f of x less than or equal to g of x, or where is g of x greater than or equal to f of x. So my g of x is here, and I want it to be greater than or equal to my f of x. Multiplying that 2 over to isolate the absolute value, we get absolute value of x minus 2 is greater than or equal to 2, which is possible. So we're going to do our positive leg and our negative leg. Okay, adding this 2 over, we get x is greater than or equal to 4. Distributing the negative or dividing, both work. We get negative x plus 2 is greater than or equal to 2. Subtracting the 2, we get negative x is greater than or equal to 0, which means dividing the negative, x is less than or equal to 0. Remember, one more time, anytime you divide by a negative, make sure you flip the sign. We also want to figure out where g of x is less than h of x. So where is my g of x less than my h of x? So again, multiplying that 2 over to isolate our absolute value, we get x minus 2 is less than 6, which is possible. So we have our positive leg and our negative leg. Adding this 2 over, we get x is less than 8. Distributing the negative or dividing, we can then figure out by subtracting the 2 that x has to be greater than negative 4. And so to identify what these values are, if I were to sketch this on my number line, we have negative 4, which is a no equals. We have 0, which is an equals, so that's a dot. We have 4, which is an equals. And we have 8, which is a no equals. Okay, for my 4, I want to be greater than my 4, so I'm headed this way. For my 0, I want to be less than my 0. For my 8, I want to be less than my 8, so they meet up. There's one region. And negative 4, I want to be greater than negative 4, so they meet up. And so my region here would be negative 4, parenthesis, because there was no equals, no point, to 0, bracket, because there was a point, there was an equals, 4, bracket, there was a point, there was an equals, to 8, no point, parenthesis. Okay? And again, there's one that corresponds to this on the graph. It's not exactly the same, but it's pretty stinking close. So you can make sure to practice that graphically. Maybe go through and graph this one after you graph the one that's on the video as some extra graphing practice if you'd like. Or conversely, if you watch the graphing one, then maybe come back or maybe go back and solve that graphing one algebraically as an extra practice of this process. Okay? But I am going to give you one more in this vein. Let's go ahead and do f of x is less than g of x is less than or equal to h of x. When f of x equals 4, g of x equals 2 times the absolute value of x plus 1, and h of x equals 12. Okay, go ahead and pause the video, restart it when you are ready. Okay, so solving this one, we first want to figure out where is my g of x greater than f of x. So where is my g of x greater than my f of x? Dividing that 2 over to isolate the absolute value, we get the absolute value of x plus 1 has to be greater than 2, which gives me a positive leg and a negative leg. Subtracting this 1 over, we get x is greater than 1. Okay, on the previous one I distributed each time, so let me divide on this one. Dividing the negative over, we do have to flip the sign. And subtracting that 1, we get x is less than negative 3. Okay. Now let's do where is g of x less than or equal to h of x. My g of x less than or equal to my h of x. Dividing that 2, we get the absolute value of x plus 1 is less than or equal to 6, which gives me a positive leg and a negative leg. Subtracting that 1, we get x is less than or equal to 5. Dividing by the negative, and so therefore flipping the sign, we get x plus 1 is greater than or equal to negative 6. And then subtracting the 1, we get x is greater than or equal to negative 7. Okay, so to determine my bounds, let's go ahead and look at this on a number line. We have negative 7, which has an equals, so it's a dot. We have negative 3, which doesn't have an equals, so it's a hole. We have 1, which doesn't have an equals, so it's a hole. And we have 5, which does have an equals, and so it's a dot. Okay? And then figuring out your regions. My negative 7, I want to be greater than my negative 7, so I'm headed this direction. My negative 3, I want to be less than my negative 3, so I'm going to head this way, and they're going to meet up. Okay, my 1, I want to be greater than my 1, so I'm going to be headed to the right. And my 5, I'm going to be less than my 5, and so they're going to meet up. And so we have our bounds here that we can find. Negative 7 is going to be a bracket because it had an equals. It was a point on the number line. The negative 3 is going to have a parenthesis. There was no equals. It was a hole. 1 had a parenthesis. Had no equals. It was a hole. And 5 has a bracket because it has an equals. It was a dot. Okay. Okay, a couple more practice problems here. I have to use some graph paper. I ran out of white paper. Okay. So let's do some rewriting piecewise. Okay, so we are rewriting as a piecewise without absolute value bars. Okay, so we have y equals negative 5 times the absolute value of x minus 6 plus 3. Okay, go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, so absolute values have those two legs, the ones we've been using just now while we were solving. we have our positive leg and our negative leg. Now for the negative leg, you can either multiply the negative to the negative 5 or to the negative 5 on the outside, or you can distribute that negative into the absolute value if you'd prefer. I usually just multiply it to the outside. The key here is making sure that you don't multiply a negative to the 3. This 3 is not part of the absolute value, so this 3 does not have a positive and negative leg. It's going to stay 3. The only thing that's changing is the absolute value piece. Okay, and then you have to figure out, okay, so where is this one getting cut? This one gets cut at positive 6, because that's what makes this interior piece 0. So it's, or opposite, if you prefer to think of it as opposite. And then you have to figure out which way is your sign going to face. So if we faced it to the positive side, or to the greater than side, we're saying that numbers greater than 6 make these equations match, and numbers less than 6 make these two equations match. And so we have to test that, right? Because if they don't match when I plug in a number bigger than 6, then I need to flip these signs. Okay, so a number greater than 6 would be like 7. Okay, if I plug 7 in, we get 7 minus 6, which is 1, times negative 5, which is negative 5, plus 3, which is negative 2. Now if I plug 7 in up here, 7 minus 6 is 1, absolute value of 1 is 1, times negative 5 is negative 5, plus 3 is negative 2. And so I know I have that one faced correctly. It's always good to double check with something less than 6 as well. So say we plugged in 0. 0 minus 6 is negative 6, times 5 is negative 30, plus 3 is negative 27. And if I take that same 0 and plug it in up here, 0 minus 6 is negative 6, absolute value is positive 6, times negative 5 is negative 30, plus 3 is negative 27. I still get them to match, and so I know I have my sign facing the right way. If they didn't match, if I couldn't get my original to match what I had rewritten, I'd need to flip those signs so that I could get true statements, matching statements. And then one of these needs to be equal. I usually make the top one equal. Okay, cleaning this up, we have y equals, distributing the negative 5x, we have negative 5x. Negative 5 times negative 6 is 30, plus 3 is 33. Down here, distributing the 5, we have 5x. 5 times negative 6 is negative 30, plus 3 is negative 27. And we've got our rewritten function. Okay. Let me go ahead and give you another. Let's do rewrite y equals 5 times the absolute value of x minus 6 minus 4. Okay, go ahead and pause the video. Restart it when you are ready. Okay, so rewriting this one, we have our positive leg, our 5 times x minus 6 minus 4, and our negative leg, negative 5 times x minus 6 minus 4. Okay. Where does this one break? In this case, this one breaks at positive 6. Okay, figuring out which way it faces. If I made this one greater than and this one less than, if I take a number greater than 6, say 7, and I plug it in, we get 7 minus 6, which is 1, times 5 is 5, minus 4 is 1. So the question is, do I get 1 still when I plug that 7 into my original equation? 7 minus 6 is 1, absolute value is 1, times 5 is 5, minus 4 is 1. They do match. It's always good to double check. Say we plug in 0, that's less than 6. 0 minus 6 is negative 6 times negative 5. It's positive 30. Minus 4 is 26. If I plug that 0 in up here, 0 minus 6 is negative 6. Absolute value is positive 6. Times 5 is 30. Minus 4 is still 26. And so since they match, I know that I have them faced the right way. If not, I'd have to flip them. And then make sure your equals gets associated with one of them. Okay? Okay. Let me do a quick look here at the topics. I know we have one more. Make sure I'm not missing any. Oh, no, it looks like we're good to go. So let's go ahead and end this review video here with our tables, the ones where you have to shade the number line. Okay. Scrolling up here, let's go ahead and give you the following table. Okay, x, f of x, and g of x. Okay, we have 0, 1, 2, 3, 4, 5, and 6 values. Okay, and we have negative 3, 2, 5, 8, 4, 0, sorry, not 0, 1, negative 2. Over here we have 0, 1, 3, 2, 5, negative 1, 3. Okay, so I'm going to ask you a series of questions about this one. Okay, I'm doing two functions because that allows me to kind of double the questions each time. So again, like before, if the first one was a little bit rough, you can kind of do the second one as well. Okay. Oh goodness, I apologize guys. I never gave you the final answer up here. We never simplified. So actually, hold off on that table. Let's simplify. Distributing the 5, we get 5x. Distributing the negative 6 is negative 30. Minus 4 is negative 34. Down here we have negative 5x. Negative 5 times negative 6 is positive 30. Minus 4 is positive 26. So sorry. Got to make sure you had that to check against the simplification process. Okay, now let's do the table. Trying the first one, pausing it, restarting it when you are ready. Okay, so first thing I'm going to ask is, on what interval, if any, can you guarantee that f of x equals 0? Okay, go ahead and pause the video, restart it when you are ready. Okay, so you could graph these and plot these points if you wanted to. That is your choice. Okay, if we were to look at our numbers as they are, to guarantee that 0 existed, I would want to see values that indicated I passed through 0. Okay, and so in this case, f was at negative 3 below the x-axis, and then was at 2 above the x-axis, which meant at some point we had to pass through 0. 0 is between negative 3 and 2. And so between 0 and 1, we do pass through 0 on f of x. Okay, 2 to 5, nope. 5 to 8, nope. 8 to 4, nope. 4 to 1, nope. But 1 to negative 2, again, 0 lies between those two numbers. We would have to pass through 0. So between 5 and 6, I pass through 0. Okay. Let's go ahead and ask this one. Can we guarantee at any point that g of x equals negative 3? Now let's do negative 5. Go ahead and pause the video. Restart it when you are ready. Okay, in this case, my values of g are 0, 1, 3, 2, 5, negative 1, and 3. no matter between which two numbers I look, -5 never sits there, right? 0 to 1, -5's not there. 1 to 3, nope. 3 to 2, nope. 2 to 5, nope. 5 to -1, nope. -1 to 3, nope. So no, or not necessarily, not necessary, because, and then something about -1 being the lowest indicated value of G, right? Or because, well, let's just say that -1 is the lowest indicated value of G of X. Okay? Okay, let's go ahead and give another one. Where does f of x equal 10? Go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, well, if I'm looking for where does f of x equal 10, f of x goes from -3 to 2, 10's not there, 2 to 5, nope, 5 to 8, nope, 8 to 4, nope, 4 to 1, nope, 1 to -2, nope, no matter which interval you're looking at, 10 never has to lie between there. So it's a very similar answer to the last one, not necessarily, because, and then something about 8 being, or 8 is the highest given value of f of x. Okay? Where does g of x equal 0? Go ahead and pause the video, give this one a shot, restart it when you are ready. Okay. Okay, this one there are some values where g of x equals 0. So 0, 1, 2, 3, 4, 5, and 6. So where does g of x equal 0? Well, g of x literally equals 0 here. I can see it. And then between 1 and 3, 3, 2, 2 to 5, and then right here, 5 to -1. To go from +5 down to -1 above the x-axis to below, I would have to cross through 0. 0 sits between 5 and -1. So on my interval 4 to 5, g of x does equal 0. And then same thing here. We go from below to above the x-axis. Between x equals 5 and x equals 6, 0 sits between that -1 and 3. So we cross again. G of x again equals 0 somewhere in that region. Okay? And then let's go ahead and ask, where does f of x equal g of x? Go ahead and pause the video, restart it when you are ready. Okay, so we have our number line here. 0, 1, 2, 3, 4, 5, and 6. And we're asking ourselves, where does f of x equal g of x? Well, this might be where you would want to actually plot these points to help you see this. Okay? But for those who are using their number line, who are using their table, I will walk through that thought process here so you can kind of consider it. Okay? Right here at our first term, who's higher? Who's bigger? G of x. Right? G of x is bigger. And on my second term, who's bigger? F of x. Right? And so if you picture that graphically, on a graph, g of x was above f of x, and then g of x was below f of x. Well, the only way for g of x to go from above f of x to below f of x is to, at some point, have them cross. Meaning at some point in this region, they have to equal, because g of x was bigger, and then f of x was bigger. They switched being bigger meaning somewhere between 0 and 1, they were equal. Okay? 1 to 2, f of x was bigger, f of x was bigger. They didn't switch, so not that interval. 2 to 3, f of x bigger, f of x bigger. Didn't switch. 3 to 4, f of x bigger, g of x bigger. So for f of x to go from above to below would require them to equal. F of x bigger to g of x bigger on 3 to 4, they are equal. Okay, 4 to 5, g of x is bigger, and then f of x is bigger. Again, they switched, so again, at some point they had to be equal. And then 5 to 6, f of x is bigger, and then g of x is bigger. And so one more time, they are equal. And again, if you graphed these points, you would see that if you prefer to use the graph. Okay? Okay, that's it. So, reviewing those algebraic topics that we just looked at, okay, we have our rewriting piecewise. This came out of Objective 3. We have our tables here out of Objective 1, okay? You have all of that solving that we just walked through, right? From quadratics in Objective 4 to absolute values in Objective 2 to cubics in Objective 5. So there was a lot here in our solving that you would want to make sure you took a look at. The only one I didn't just name was Objective 6. Objective 6 was a graphing portion, so that is in the other review video. So I would encourage you again to go take a look at that to add to the review. Okay? Good luck studying.